Hello students, now we will continue the vectors. The concept name is equilibriant. What about the equilibriant? Otherwise it is called equilibrium also. Here the statement for equilibriant is a vector having same magnitude and opposite in direction to that of a resultant of number of vectors is called the equilibriant. A vector have same magnitude and opposite in direction to that of resultant of a number of vectors. Whatever may be the vectors you can take, either 2 vectors or 3 vectors or 4 vectors. It's a resultant acting in one particular direction. For example, it is one vector. It is one vector. These 2 vectors resultant acting this direction. It is a resultant vector. Now one more vector can take opposite direction, and this vector magnitude and this vector magnitude both also same. Then the net force acting on this particle equal to 0. Then the particle at equilibriant. It means the net force acting on a particle equal to 0. Simply can say also that the net force acting on a particle equal to 0, then it is at equilibrium also can say. But here net force y0 means here 2 vectors are acting. It's a resultant acting this direction. But one more vector you are taking opposite direction of resultant of the vectors. It is having same magnitude of the resultant and opposite direction of the resultant. So net force, otherwise net vector acting on this particle equal to 0. Then it is at equilibriant. Or one more statement have see, negative vector of the resultant of resultant of a number of vectors. Negative vector of the resultant of a number of vectors is called equilibriant. Number of vectors mean can take here also. It is one vector. It is one vector. It is one vector. These 3 vectors resultant acting this direction. It is A bar vector can take. It is B bar vector can take. It is C bar vector can take. Now this is the resultant vector can take as a R bar for example. Now one more vector can take opposite direction of it is. This is R bar means this vector name is called as a minus R bar. Actually these 2 vectors are having that same magnitude but act in opposite direction. So negative vector of the resultant of a number of vectors is called equilibriant. If F1 bar, F2 bar and F3 bar are the 3 forces acting on a body, then the resultant force is, what is the resultant force here? Force is the vector quantity. Force is the vector quantity. So resultant force can write as a the vector sum of the forces acting on a body. The vector sum of the forces acting on a body. It is not a algebraic sum. Vector algebraic sum it is. So resultant force can take F1 bar plus F2 bar plus F3 bar it is. It is the resultant force. Now if this particle at equilibrium means these 3 forces here can take one simple diagram. It is one force, it is another force and it is one more force can take. This force name is F1, it is F2 and it is F3. These are 3 resultant acting this direction. For example, just I considered like Fr. Now its negative vector you are taking exactly opposite direction required. Exactly opposite direction can take. It is minus Fr bar it is. Then this particle at or this body at equilibrium. It means if the net force acting on a particle or the net force acting on a body is 0, then the body or particle at equilibrium. Here some note points will observe. Single force cannot keep the particle in equilibrium. If any particle you are taking, if any particle will take, for example here one particle taken, only one force acting that, this force cannot keep at a equilibrium. Because of when the force acting on a particle, single force only acting on a particle, then the particle is moving along the direction of the force. Next, minimum number of equal coplanar forces required to keep the particle in equilibrium is 2. Here minimum number of equal coplanar forces, it's mean, for example, here one body taken, right side 5 Newton force acting, left side also 5 Newton force acting. Then the net force acting on a body equal to 0, because of right side force can take positive, left side force can take as a negative, that the net force acting on the body equal to 0, then the particle or the body at equilibrium. So here minimum 2 forces are required, but both forces are equal magnitude. Next, minimum number of unequal, here unequal coplanar forces, here equal coplanar forces. These 2 points try to identify. Here minimum number of unequal coplanar forces required to keep the particle in equilibrium is 3. Here unequal forces, it is one force, for example 3 Newton, it is one force 4 Newton. Now these two forces result in acting this direction 5 Newton. Now its result, one more force can take minus 5 Newton, opposite direction it is. Now this particle at equilibrium. Actually this 5 Newton is resultant of 4 and 3, but on these are unequal magnitudes, but both are in that same plane only have. These two resultant acting this direction. Here one more third force I taken, minus 5 Newton. So here what are the forces acting on a particle means, one is the 3 Newton, 4 Newton and 5 Newton. Then the particle at equilibrium. Minimum 3 forces are required when unequal coplanar forces are acting on a body. Next, minimum number of equal or unequal non-coplanar forces required to keep the particle in equilibrium is 4. In space it is actually, it is in the 2-dimensional plane, it is also in the either linear direction can take it is, but it is can take as a 3-dimensional space. Here 3-dimensional coordinate system, otherwise space can take it is. Minimum number of equal or unequal forces you are taken also, how many required to keep the particle at equilibrium means 4 forces minimum will be required that. Next, here one question say 3 forces F1 bar, F2 bar and F3 bar act simultaneously on a particle. At the same time these 3 forces are acting on a particle. If the particle is in equilibrium, the value of A is, here asking the value of small a. Here where you have the A means in the force F given, F1 given, A it is. But here when the 3 forces are simultaneously acting on a particle, the net force acting on the particle equal to 0, then only the particle at equilibrium. So right here F1 bar plus F2 bar plus F3 bar equal to 0. The net force acting on or resultant force acting on the particle equal to 0, that is. Then F1 equal to take here A, here I cap, next minus A j cap, next plus A k cap. Here A I cap minus A j cap plus A k cap. F2 bar will see. Here F2 bar 2 I cap minus 3 j cap plus 4 k cap plus 8 I cap minus 7 j cap plus 6 k cap, that is equal to 0. First here write I cap, take common those values, write here first A, next here AI, here 2I and 8I, A plus 2 plus 8 I cap. Next j cap terms take, here j cap terms taken plus j cap take common minus A, here minus A have beta, next minus 3j minus 3, next minus 7j minus 7 can take. Next k cap take common plus k cap of, here first have the A common coming, next here 4k plus 4, next here 6k plus 6, that is equal to 0. Here write a plus 10, a plus 10 I cap. Next, here a minus 3 minus 7 minus 10, minus take common, here minus a plus 10 j cap. Next, plus a plus 10 k cap. That is equal to 0 have actually. This 0 you can write 0 I cap plus 0 j cap plus 0 k cap can take. Both sides can equate the magnitudes. Here a plus 10 I cap, there 0 I cap have. Other second term also can equate j cap magnitudes or k cap magnitudes also can equate. You will get same answer only then. Here a plus 10 equal to 0. So write here a equal to minus 10. J cap term taken also a plus 10 equal to 0. So write here a equal to minus 10 only. Otherwise k cap terms can take a plus 10, that is equal to 0. Here a equal to minus 10. They are asking the value of a. A find out that. Like it is the method to solving questions about equilibrium. Next, application based on the equilibrium concept only, Lami's theorem will be working that. Lami's theorem. If three coplanar forces acting at a point keeps it in equilibrium, then each force is proportional to the sine angle between the other two forces. We will see the statement. If three coplanar forces, these are three coplanar forces, F1 is one force and F2 is one force and F3 is one force. Coplanar means these three forces are acting in that same plane only. Either xy plane can take or yz plane can take or zx plane can take. Acting at a point, these three forces are acting at that same point, see that, at this point only acting that. Directions are given away from the point. At a point keeps in equilibrium. This point is keeps in equilibrium. When this point at equilibrium, then only this condition applicable. What is the condition? Then each force is proportional to each force. Any one force also can take. For example, F1. Each force F1 proportional to sine angle between, sine of the angle between other two forces. Here F1 force when considered, remaining two forces are F2 and F3. Sine angle between the forces, alpha it is. F1 is directly proportional to sine alpha can write. Otherwise, F2 for example taken, here F2 is directly proportional to opposite direction. It is F2 when considered, then remaining two forces F1 and F3, angle between them beta. F2 is directly proportional to sine beta. Like one more also can take F3. F3 is directly proportional to opposite direction, angle C, sine gamma it is. So right here from these three equations also can take F1 by sine alpha. From this equation can write F1 by sine alpha equal to constant. Or from this can take F2 by sine beta equal to constant. Or from this can take F3 by sine gamma equal to constant. That is only writing here equation C. F1 by sine alpha equal to F2 by sine beta equal to F3 upon sine gamma. But here if you observe, if F1, F2, F3 are the magnitudes of the three forces and alpha, beta, gamma are the angle between the forces F2 and F3, F3 and F1, F1 and F2 respectively, then according to the Lami's theorem, F1 is directly proportional to sine alpha, F2 is directly proportional to sine beta, F3 is directly proportional to sine gamma. So its ratio can take, here can write F2 by sine beta equal to constant can take, or F3 by sine gamma equal to constant can take. These three constants also same, it is and it is and it is also. So these three equations are equated, will get f1 by sin alpha equal to f2 by sin beta equal to f3 by sin gamma. It is a Lami's theorem. Next, here one question related to that Lami's theorem. A rope extends between two poles, a 90 Newton body hangs from it as shown in the figure. It is hangs, not a hands, hangs from it as shown in the figure. Find the tension T1 and T2 in the two parts of the rope. Here a rope extends between two poles. This is like a 2 points can take, here 1 point and here also 1 point have, like hanging that. A 90 Newton body hangs from it as shown in the figure. Here 90 Newton body, here body also can just you can take like. But that weight is 90 Newton body is hanging by that. Find the tension T1 and T2 in the two parts of the rope they are asking. What is the T1 and what is the T2 they are asking. Here how many forces are acting in the diagram if you are observe? T1, T2 and 90 Newton. Now this point at equilibrium, when the particle at equilibrium or that point at equilibrium can apply the Lami's theorem. About that Lami's theorem, this angle 30 given, this angle 60 given, so this angle is 90 can take, because of this total angle equal to 180. So that angle between T1 and T2 is 90, it is 30, this angle is 90, it is 60, this angle is 90. So this total angle 150, this total angle is 120, that is. Now these three angles also you know. According by the Lami's theorem, with help of Lami's theorem, we will find the T1 and T2 values. They write T1 by T1 upon T1 opposite angle C, 60, 90, 60 plus 90, 150. So take sin 150. It is very easy, 150 degree it is, that is equal to, next tension T2 can take opposite angle C, 30, 90, 90 plus 30, 120. So write T2 upon sin 120 degree, that is equal to, here this force is 90 Newton, opposite angle is 90 degree. So write here 90 Newton upon sin 90. Now these three also equal that. Now calculate T1 value and T2 value 1. Here these two, first term and second term are equal, and first term and third term also equal it is. So write here T1 upon sin 150, will write sin 90 plus 60, that is equal to 90 upon sin 90 value is 1. Here take T1 upon sin 90 plus 60 cos 60. In the second coordinate sin function is positive, but here 90 have, so sin function will become a cos 60. That is equal to 90 by 1 means 90 only it is. Now T1 equal to, they write 90 cos 60. Do you know the value of cos 60? Cos 60 equal to 1 by 2 it is. So 2 ones and 2 45s. Here write T1 equal to 45 Newton it is. It is the calculation of T1. Next to T2 value. About T2 also, these two terms, second term and third term will equate it. Here take T2 by sin 120, sin of 90 plus, that is equal to 90 upon sin 90 value is 1. So write T2 by sin 90 plus 30, cos 30 can take, that is equal to 90. So take here T2 equal to 90 into cos 30. Do you know the value of cos 30? The value of cos 30, here T2 equal to 90, cos 30 value is root 3 by 2. Here 2 ones and 2 45s. So write here T2 equal to 45 root 3 Newton it is. It is the question related to Lami's theorem. With help of Lami's theorem, like the questions can solve it. Next, here one more question, see. One more question, see. For coplanar, concurrent forces are acting on a body as shown in the figure. To keep it in equilibrium, value of P and theta are. Here, four concurrent forces means these three forces also acting in that same plane only, but this particle at equilibrium, they are asking this unknown value P1 is and this unknown angle theta, these two are asking that. But here four forces are acting that coplanar. Then here with help of Lami's theorem means with help of three forces only can solve that. But here when four forces are acting, here using the method of resolution it is. Here how to use the method of resolution mean, here this force is acting horizontal direction or x direction. This force acting along the y direction. These two forces are David. But this force acting along the slant, making some angle. It is not along the x axis, not along the y axis also, making some angle 60 degree with the x axis. So this force can resolve it. Now for this resolution in the direction can take 2 cos 60. Here is angle have, so in the direction horizontal component act or cos component acting, normal to this component vertical component will act 2 sin 60. Next, here P also acting along the slant, but here angle theta. So it is also for this P, this direction vertical direction P cos theta acting that. In horizontal direction P sin theta acting it is. Now this particle at equilibrium, when this particle at equilibrium, net force acting on the particle equal to 0. So along the positive x direction force, along the negative x direction force, both are equal. Then only no force acting along the x axis. Here positive x direction, see 1 Newton plus second one is 2 cos 60, that is equal to left side force can take P sin theta, right side force equal to left side force. So it is can simplify 1 plus 2 cos 60 value is 1 by 2, that is equal to P sin theta. So 2 cancel it, 1 plus 1 equal to 2. Here 2 equal to P sin theta. This is one equation can take. Here P also unknown value and theta also unknown value that. Next along the y direction can take one more equation will get. Upward force equal to the downward force or positive y direction force. Sum of the force acting in positive y direction equal to sum of the forces in the negative y direction also can take. In positive y direction force is root 3 plus P cos theta. In downward direction can take 2 sin 60. 2 sin 60. So here take root 3 plus P cos theta, that is equal to 2. Sin 60 value is root 3 upon 2. Here 2 cancel it, P cos theta. P cos theta equal to root 3 minus root 3, 0 that is. So P cos theta equal to 0. Here cos theta equal to 0 upon P. 0 by anything equal to 0. So cos theta value 0 means theta equal to 90 degree. Here the value of theta equal to 90. When you know the value of theta, you can calculate P also. One question complete, theta value find it, P value. So this equation can take here 2 equal to P sin theta. Here write 2 equal to P, theta value 90, sin 90. The value of sin 90 equal to 1. So write 2 equal to P into 1 it is. So write here P equal to 2 Newton. Here when more than 3 forces are acting, how to apply that? 3 forces are acting only, Lami's theorem is applicable. More than 3 forces means then using that method of resolution only.